At the time, it was the most powerful artificial explosion in human history, but it wasn't supposed to be. On March 1st, 1954, the United States detonated the country's first thermonuclear, or fusion, bomb at Bikini Atoll in the Marshall Islands, a small coral reef and 23 islands almost equidistant from Australia, Japan, and Hawaii. In the days and weeks following the blast, the United States would pay out millions of dollars in settlements, thousands of islanders would be evacuated and re-evacuated, and the Japanese public would deem the test a second Hiroshima, a comparison no citizen would dare make lightly. This is the true story of Castle Bravo. The Castle Bravo device sat silently and sun-kissed in the morning of March 1st. It was housed in an ugly concrete bunker constructed on an artificial island on a beautiful reef off Namu Island in Bikini Atoll. An array of parallel vacuum tubes ran from the bunker to a data bunker 2.2 kilometers away, ready to measure various variables. Numerous towers with mirrors rose up out of the man-placed sand at different distances, ready to reflect the first few milliseconds of the explosion's light to ultra-fast and very distant cameras before the towers themselves were vaporized in what was to follow. Within 1 second of the explosion, the fireball of the US's first fusion bomb was almost 5 miles wide and hotter than the sun. Almost just as quickly, the civilians, scientists, and military personnel in attendance knew that something was unspeakably wrong. Within 1 minute, the mushroom cloud was higher than most commercial planes fly. In under 10 minutes, the results of the explosion would be 100 kilometers wide. For context, 100 kilometers is the same distance from the surface of the Earth to space. The fireball was reportedly seen up to 400 kilometers, or 250 miles away. As L. Douglas Keeney writes in 15 Minutes, General Curtis LeMay in the Countdown to Nuclear Annihilation, quote, "In mere seconds, the sailors sensed that something unspeakably wrong was occurring. Battle-hardened men who had served in World War II went to their knees and prayed." End quote. The indescribable flash of light from the fireball made the bones of nearby men visible through their flesh, like shining a light through a chicken egg an embryo does. Sailors on Navy ships said that the heat that followed the blast felt like a blowtorch running over the side of their bodies facing the bomb, and they were 30 miles away. What caused the worst disaster in America's atomic testing history was simple. Castle Bravo's yield was supposed to be 6 megatons of TNT equivalent energy, and it exploded with 15. The Castle Bravo device was housed in an unassuming metal cylinder that weighed 23,500 pounds and was about as wide in diameter as most people are tall. Now, there are many things that make the engineering and design of the ironically named shrimp device interesting, but to make the nuclear physics here as simple as possible but not simpler, Castle Bravo was a thermonuclear bomb. Unlike fission bombs, which use conventional explosives to compress radioactive material down into critical masses, thermonuclear weapons use fission bombs to kick off a fusion reaction, which needs much more temperature and pressure, hence the thermo part of thermonuclear. Very basically, a thermonuclear weapon works by chaining together increasingly destructive stages. The first stage is the primary, a fission bomb like was detonated above Hiroshima. That bomb is engineered to release its obscene amount of energy into the interstage, where expanding hot gases, plasma, radiation, and neutrons are directed via the casing's geometry and material engineering at the secondary, a reservoir of fusion fuel. Now, bombarded by neutrons, incredible heat, and a pressure 1,000 times that at the center of the Earth, this fuel undergoes fusion, a process that can release many times more annihilating energy per kilogram than fission does. This, in essence, is how all thermonuclear weapons operate, and in theory, a secondary stage could be used to ignite a third or tertiary stage of fusion and beyond. It is speculated that this is how Russian scientists ignited the largest bomb ever detonated, the so-called Tsar Bomba, an explosion so unimaginably immense that measurements at the time showed the resulting shockwave circled the planet 3 times. Fusion is ferocious. The Castle Bravo device used a solid fusion fuel called lithium deuteride, an isotope of the element lithium with 6 neutrons bonded with an isotope of hydrogen with a single neutron, or deuterium. The enriched lithium used in the bomb was 40% lithium-6, which, when bombarded by neutrons from something like a fission reaction, completes an exothermic reaction to form the radioactive sort of hydrogen with two neutrons, known as tritium. Inside the hell that is a nuclear explosion, tritium and deuterium fuse to produce helium, a neutron, and a relatively large amount of free energy, the energy that makes a bomb a bomb. Lithium-6 deuteride is the primary fuel in thermonuclear weapons, and in the Castle Bravo device, it was also the fuel for the critical miscalculation. It was assumed that the enriched lithium-6 would be the only source of the bomb's energy, and that the 60% of the fuel that was lithium-7 would be inert, that it wouldn't react at all. And then it did. The day before Bikini Atoll gained a crater, the salty ocean wind was blowing, as expected, to the north. Nobody was north. In the early morning hours of March 1st, 1954, however, the wind unexpectedly and dramatically shifted to the east, over an area where a small but very present population of islanders lived. In the declassified film Operation Castle, the task force commander Major General Percy Clarkson indicated on a diagram that the wind shift was still in the range of, quote, acceptable fallout. When the Castle Bravo casing, bunker, and artificial island became a blinding ball of plasma, it created a crater 2,000 meters wide and over 75 meters or 250 feet deep. What was inside that crater just milliseconds before was coral reef and sand, and now pulverized coral, radioactive and falling like ash, was being carried on an unexpected wind toward an unexpecting people. 20,000 people resided in the path of possible fallout, and the residents of the Rongelap and Utterick atolls were hit the hardest. They would soon feel the effects of radiation sickness, but they wouldn't be evacuated for a full 48 hours.
Every effort was made to assure the comfort and well-being of the natives. Radiation survey teams will be flown back to the atolls, in which time soil and water samples will be taken. Data obtained from evaluation of these samples will be very valuable in the Gabriel studies.
It would be 3 years before the former residents of Rongelap were allowed to return by the United States' Atomic Energy Commission. When the islanders began to put the pieces of their life back together, though, the fish were making them sick, and the crops were either gone or again sickening. There was cesium-137 in the coconut milk. The 82 residents allowed to return had to be re-evacuated. By 1963, 9 years after the bomb, according to secretive medical studies, the natives of the larger Marshall Islands were developing thyroid tumors. When Bravo detonated, 29 children eventually encountered fallout, and 20 of them developed tumors. The women of the islands now had a mortality rate for cervical cancer 60 times higher than that of the American women on the mainland. Breast and colon cancer risks increased by 5 times, lung cancer by 3 times. Birth defects were reported. Island men started dying from oral cancers at a rate 10 times what it was before Bravo. The Castle Bravo explosion eventually contaminated more than 7,000 square miles of the Pacific Ocean. 15 islands and atolls were affected, 253 residents felt some form or consequence of radiation sickness, and by 1995, the Nuclear Claims Tribunal reported that it had awarded nearly its entire fund, $43.2 million, to 1,196 claimants for 1,311 radiation-induced illnesses. The fallout from the Castle Bravo test was the worst in human history. The designers at the Los Alamos National Laboratory had made a mistake. Castle Bravo's fusion fuel was 40% lithium-6 and 60% lithium-7, an isotope with an extra neutron. At the time, lithium-6 was scarce and expensive, so a compromise was made to add lithium-7 to make up the rest of the mixture. And it was that compromise that led to something that some of the smartest people on the planet either discounted or just didn't expect. During the fusion reaction in the secondary of a thermonuclear bomb, the inert lithium-7 is supposed to absorb a neutron, become lithium-8, and then decay into 2 helium nuclei in about a second. Now, 1 second is extremely quick, but on the timescale of a nuclear blast, it might as well be a lifetime. The thinking was that when everything is over in just milliseconds, it shouldn't matter what some element like lithium-7 did when it could have already been vaporized 1,000 times over in a fireball. This was the mistake. You see, in everyday physics, lithium-7 should behave as we just described, but in the atomic apocalypse that is a fusion reaction, lithium-7 is hit with neutrons with vastly more energy. Smashed by high-energy particles, lithium-7 almost instantly decays into a helium nucleus, tritium, and another neutron. If you recall, tritium is the real fuel of a thermonuclear device, and neutrons are the particles that sustain the chain reactions of both fusion and fission. The result was a much more efficient fusion reaction than calculated by Los Alamos scientists. What was supposed to be a 5 megaton bomb detonated with 15 megatons of TNT energy equivalent, 60,000 trillion joules. Because of this so-called tritium bonus, the blast of Castle Bravo had the same total energy as all the bombs the Allies dropped during World War II combined. The 23-man crew of the Japanese fishing boat Daigo Fukuryu Maru was supposed to trawl for tuna near Midway Atoll. Instead, after losing many of their nets in the Midway Sea, they changed course. They now headed to the south, towards the Marshall Islands and towards Bikini Atoll. On the morning of March 1st, the Lucky Dragon was unknowingly just a few kilometers outside of the projected danger area for the Castle Bravo test. The small fishing vessel was not detected on radar or by spotter planes in the air that day, and so wasn't warned off by the US military. And, as fate would have it, the unlucky ship was also to the east of Bikini Atoll that day, where the wind wasn't supposed to be blowing. The Lucky Dragon wasn't damaged by the blast, but like the test personnel watching, the men witnessed an expanding light brighter than the sunrise. As one of the fishermen wrote in a journal, quote, 9 minutes later, a roaring sound arrives like overlapping avalanches. Bang, 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 an awful sound like the Marshall Islands are sinking as angry waves into the sea. End quote. The men, spooked but with a job to do, resumed fishing. Soon, though, a ghostly white rain and a sort of dust descended on the vessel and the surrounding sea. Still fishing, they scooped up the dust into bags with their bare hands for disposal. One of the men, Oshi Matashichi, reported that when the dust started to fall, he took a lick of what he described as powdered snow. He said it was gritty and had no taste. He didn't know what it was. It was atomized sand and coral from the Castle Bravo explosion, and it was contaminated with strontium-90, cesium-137, selenium-141, and uranium-237. The dust stuck to their clothes, got in their eyes, inside their noses and ears, accumulated in their underwear, settled in their lungs. Understandably alarmed by the oddly colored rain and ash, the crew set into hauling all the lines and processing all the fish to escape the area, get back to Japan as quickly as possible. But quickly was a full 6 hours. Radiation sickness set in before they were done. Dizziness, vomiting, fever. A direct course back to their home port of Yaizu, Japan, was charted, and the 23 men arrived almost 2 weeks later on March 14th. They were all about to experience what would render the islands surrounding Bikini Atoll uninhabitable for years. When it was first docked at the fish market in Yaizu, you could detect the irradiated ship from over 100 feet away. Over the next few days, the entire crew of the Lucky Dragon No. 5 would be transferred to Tokyo University Hospital. Some would remain there for up to 14 months, and one man wouldn't remain at all. The crew was constantly monitored by Japanese doctors and scientists. Daily blood samples revealed internal hemorrhaging and reduced blood cell counts. They had constant fever and diarrhea. They bled from the noses and gums. They had reduced sperm cell counts or no sperm cells at all. The prescription was rest, antibiotics, and many blood transfusions. Radiation was attacking their bone marrow so intensely it was interfering with their body's ability to make blood cells in the first place. And to add insult to grave injury, contamination in the hospital at some point during the multiple blood transfusions gave all the crew hepatitis. In the third week of August, Kubayama Akichi started to die. He had presented with meningitis, forced doctors to strap him to the floor with madness, and fell into a coma and developed pneumonia. Kubayama became the first victim of a thermonuclear bomb when he died on September 23, 1954. Though the rest of the Lucky Dragon's crew would be released the following May in 1955, another crewman died 6 months later, and another still reported a pregnancy that ended with a stillborn, deformed child. The Japanese public would come to call the white ash and rain that painted the unlucky fishermen that day Shinohai, or death ash. The official position of the United States after the Castle Bravo test was that the danger zone for fallout did not include the Lucky Dragon and denied that its crew had been exposed to any fallout whatsoever. It also claimed that the unexpected yield increase did not equal an unexpected increase in radioactive fallout. When the United States later expanded the danger zone for the test, the Lucky Dragon joined an estimated 100 other ships exposed to some sort of death ash. Obviously, as the news about Castle Bravo got out, panic and political pressure followed. One zenith of public outrage came when Sir Joseph Rotblat, a Polish physicist, published a paper questioning the official reports, and he was the perfect man to do so. Rotblat had felt personally betrayed that nuclear bombs were used on Japanese cities to end World War II, and had recently done months' worth of lectures on why all research on nuclear weapons should cease. And so, after Castle Bravo, Rotblat did the physics himself to reveal not only that Castle Bravo was a multi-stage weapon for the first time to the public, it was 1,000 times more radioactive, more dirty, than what the United States was claiming. Why would anyone believe this lone scientist? Well, in 1944, Rotblat wasn't lecturing or teaching or railing against nuclear weapons. He was working on the Manhattan Project. He was the only scientist to leave the project on grounds of conscience. While the Americans were downplaying the true cost of Castle Bravo, Rotblat published his paper, which was quickly and understandably picked up by an increasingly tense Japanese government and public. The resulting outcry in Japan strained diplomatic tensions to the point of breaking, and they almost ceased altogether. Some of the Japanese public and government officials had dubbed the fallout from the Castle Bravo test a second Hiroshima. The two countries eventually came to an agreement, though, and the US transferred $15.3 million to Japan, as well as the equivalent of $53,000 to each of the surviving Lucky Dragon crew members. Joseph Rotblat's paper and the incident overall was a real turning point in public awareness of the dangers posed by nuclear weapons. And so in 1963, the world's governments would ban atmospheric nuclear testing, and Rotblat would win the Nobel Peace Prize in 1955. The Castle Bravo test was about 1,000 times more powerful than each of the atomic bombs that were dropped on Hiroshima and Nagasaki, and is the fifth largest nuclear explosion in history. International furor over a simple mischaracterization of lithium meant that the US was forced to reveal that it had the ability to make deliverable thermonuclear weapons, and more importantly, it had to reveal that information to Cold War adversary Soviet Russia. The test was supposed to be a secret. The gaseous fallout from Bravo eventually spread as far as Australia, India, Japan, the United States, and parts of Europe. But not everything that happened as a result of Castle Bravo was so bleak. The radioactivity of Bikini Atoll is a favorite theory of the origin of the mega-popular cartoon SpongeBob SquarePants, and gazing at a crater while flying over Bikini Atoll in 1954, film producer Tomoyuki Tanaka would go on to create a film to really capture Japanese fears of nuclear annihilation. It was a monster movie that opened with a fishing vessel encountering radiation, and that film was the original Godzilla. And if you want to see history for yourself, the Lucky Dragon was deemed safe for public viewing in 1976 and is currently on display in its own museum in Tokyo. It was this ship, barely 100 feet long, that was the catalyst for worldwide calls to ban atomic weapons testing and made fallout a word that everyone now knows and fears. Until next time. Thank you so much to the very nerdy staff at the facility for the direct and substantial support in the creation of this kind of depressing video. Today especially, I want to recognize research assistant Jenny Dowd and visiting scholar Patricio Nomenbuena. If you want to join the facility staff, if you want to don a silky white lab coat, talk with me on Discord every day, get behind the scenes stuff, get videos early, you can go to patreon.com/KyleHill, join the facility today. And if you support us just enough, get your name on ARIA here each and every week. And as you can see, there's literally hundreds of you, so I have no idea how we're going to pass the time. In fact, I'm going to let you sit with this one. Yeah, kind of intense. I know. I wrote it. Thanks for watching.